Hi team, welcome to CodeXeq. Today we are going to talk about agentic AI, that is AI agents, and we are going to crisply explain how the regular AI that we are seeing today is slowly evolving into AI agents and what are the demands, user use cases that are pushing this evolution, right? Let's just quickly talk about how AI is working today. AI majorly works today because of LLM, which is a very powerful tool. LLM today can do all of its tasks on its own. Example, it can write its own blog when user asks it. It can write code, right? There are multiple use cases as such where LLM can do. But what if we want to scale it? What if we want LLM to work with different tools that we have in place? Example, in the real world use case, you want LLM to talk to your own Jira, or you want LLM to talk to your own Confluence that you've set up. That requires separate bridges to build. If you need that kind of application or that kind of use case to work, then you will have to work with separate individual tools where LLM needs to individually build bridges, which is very tough to scale, right? So that is where MCP comes into picture. MCP is a protocol which is called a model context protocol. The way model context protocol works is we have an MCP client and we have an MCP server, and there is a communication between LLM, MCP client and MCP server, which eventually takes care of any task that you throw at it, and it works in an agentic AI fashion. Example, few of the major components that we have is MCP client, right? And you have each of your tool will have their own MCP server that is built by the tool owner, right? So the way eventually agentic AI works is when a user makes a request to LLM, like example, hey, can you search this Jira particular tickets for me? And can you just summarize all these Jira tickets into a Confluence page, right? That is an entire task, which has separate broken down works that a single LLM cannot handle. In this case, what happens is a user sends a request via LLM to an MCP client. We have multiple MCP clients today in the market. Example, one of them is Klein, right? Klein is a perfect example, I would say. It is an MCP client which can talk to multiple MCP servers. We don't need to build separate bridges to each server. The way MCP client works is, okay, taking one step back, the way MCP client works is we need to configure multiple of MCP servers to a single MCP client, right? Like client. And whenever user sends a request to, let's say, do a task, MCP client will figure out which particular server it needs to talk to, and it makes a call to the server. It makes a call to the server and does the tasks and responds back. So let's take data flow. We have a user here, right? User makes a request, right? Then LLM sends a request to MCP client, like client, right? Level 1. Then MCP client, it figures out what the ask is. If the ask is that, like I was mentioning earlier, to make a Jira search and summarize tickets and put it in Confluence, MCP client figures out and forwards his request to Jira, right? This Jira as a tool processes this request and responds back to the MCP client, and MCP client has the compiled data here. Now MCP client's next task is to make sure it forwards this request again to MCP server of Confluence, right? Then this summarized data is mapped into Confluence, and Confluence server responds back to MCP client. Now MCP client has a furthermore compiled data. This compiled data is generated, and this MCP client responds back to LLM and then is responded back to the user. That is how the entire flow is happening. It is not just easy to scale, it is easy to trust, and it is easy to configure, because we are not building individual bridges and we are not trying to create larger applications. Rather, we are making it very abstract. We are making it more easier to configure and add more. So in future, if you have more tools coming in, there is a way that you can easily configure all the servers in a single list. So example, in a client, MCP client, there is a settings.json example. We can configure all of these MCP servers in a single file, and LLM will take care of the entire tasks and sends back to user. Right? That's a little bit of crisp explanation. Thank you so much.